Okay, in this tutorial we're going to be looking at Quartic functions and other higher order polynomials. Okay, so the general form for our Quartic is y equals ax to the 4 plus bx cubed plus cx squared plus dx plus e. Okay, so we're getting pretty complicated now. Now we've got lots of factorized forms, okay, that can all make our graph look a little bit different. So our first one, which is y equals a outside of x take x1 to the power 4, which is very similar to our turning point form, has this general shape. So it pretty much looks like a quadratic, except you'll see that the bottom is flatter than what a quadratic is. And that's basically because of our values between -1 and 1, okay, our fractions. Okay, as we do a fraction to a higher power, then our answer gets smaller, quicker. Okay, so we end up with this flatter bottom. Okay. Our next one is y equals a outside of x take 1 times x take 2, sorry, x take x2 cubed. Okay, so you see here we've got one linear factor or intercept. We call it linear because it looks like a straight line there. This one's like a cubic factor. You can see this general cubic shape here. Okay, so it's to the power of 3, that intercept will look like a cubic. Okay, when we've got the next one, y equals a outside of x take x1 squared times x take x2 squared. Now this one, we're going to have two intercepts, both of which are going to look like a parabola. Okay, so they're coming down and touching because they're both squared. Okay, our next one, we've got y equals a outside of x take x1 times x take x2 times x take x3 squared. So in this case, we've got two linear intercepts from these ones, and then one quadratic intercept, looking intercept, okay, because it's squared. Our last one is our one with all linear intercepts, so we've got y equals a outside of x take x1 times x take x2 times x take x3 times x take x4. So all of these are linear intercepts. Okay? As we go up to our higher powers, essentially the same thing just keeps repeating itself. Okay, when we go up to our higher ones, okay, with more terms, if we've got a higher power term, so we had a power that was to the power 4, then really the intercept's going to look like this. It's still going to be quadratic in sort of parabolic in sort of nature, but again have a bit of a flatter bottom than these intercepts do. And same with if we had one that was to the power 5 rather than power 3. Okay, again, it's going to look like a cube, like that general cubic shape, but it'll be a bit flatter either side of our actual intercept. Okay, so this is pretty much all our different forms that we're going to see. Of course, if we had higher degree and we had more factors like this, essentially it's just going to be more troughs and crests along the way. Okay, when we have a look at our actual turning point form, okay, which is y equals a outside of x take h to the power 4 plus k, very similar to the first form that we saw, except we've got this plus k. What we get here is that we end up with a turning point that's a stationary point at the bottom there, okay, at hk, just like what we've seen in the past with our actual turning point form when we had a quadratic. Okay, again, the only difference is it's going to be a little bit flatter here. Okay, all of those forms that we saw are all the shape is governed by the value of a. So if a is positive or bigger than 0, it's going to be starting up, so it'll be coming down from both sides, if you like. Okay, and if a is less than 0, so it's negative, then it's going to be up the other way. Okay, and again, we see more about transformations in sections a bit later on. And again, as we said, we've got this stationary point there at hk. Remember, you need to change your sign. Okay, our higher order polynomials. Now, we talk about our higher order polynomials in our turning point form rather than the general form, because the general form just keeps getting longer and longer and longer. We'll be quite succinct here with our higher order polynomials. So really all we're doing is changing this degree up here. So n is the degree of our polynomial. So remember, quadratic is degree 2, cubic degree 3, quartic degree 4, and so on. Okay, when n is even, okay, like we've got now, then we're going to end up with this general parabolic shape. Okay, however, we're going to keep getting flatter in that region towards the turning point. And again, that's because, say, if we have a half, or we squared it for a quadratic, it's going to give us a quarter. Okay, when we went for our quartic, though, it's now to the power 4, so it becomes 1 on 16. Okay, then we'll keep going. When we get to power 6, it's going to be 1 on 64. Okay, so you can see that when we input this value of a half, okay, our output keeps getting smaller and smaller and smaller. And that's going to be the same whether it's positive or negative a half. So we keep getting flatter and flatter bottoms to our cortex, okay, as that degree gets higher. Okay. Similarly, when n is odd, we can see that here with this graph that I've done. Okay, so we've got this parabola here, okay, this quartic here, so it's still going to come through these same points, which is going to be 1 and -1 and 1. They're still going to be the same values, okay, so we're always going to cross there, but you can see we drop down lower and have this flatter bottom as our powers go up. Okay, similarly, when n is odd, the shape will resemble a cubic, okay, but it'll be again flatter. Okay, so again here is going to be -1, here is going to be +1, so we've got those shared points. Okay, but you can see that as we keep going up our powers, we're going to get flatter between -1 and 1. Okay, for the same reason as I just mentioned before. Okay, keep moving on. Okay, so if we look at factorizing quartics and high degree polynomials, okay, there's no real point doing an example on this because it will need to be completed almost exclusively via division of polynomials, which you can check out in another one of my videos of how to go through that process. Okay, what we're going to have a look at now though is doing a couple of sketches. Okay, so we want to sketch a graph of y equals -3 x take 1 times x take 2 times x take 3 squared. Okay, so from this negative value, we know that overall our shape is going to be like this. Okay, so we're going to start low. And here we can see what our intercepts are going to be, and by our degree we can see what their nature is going to be. So remember, we've got to change these signs. So x equals 1. Okay, we've got there. We've got -2. Okay, and we've got +3. Okay, now we know this -1 is, we know we're going to start from down here somewhere. Okay, we know the -2 one is a linear intercept. 1 is a linear intercept. Okay, and our -3, okay, is a parabolic intercept. So it's going to be like that. Okay, so we can see that we can do something like this. Oops. Maybe this sort of a shape. Now what we haven't done is looked at what our y-intercept would be, which would be the other option, which is when x equals 0. So when x equals 0, we've got -3 times -1 times 2 times -3. Okay, so we've got here 3 times -3 is -9 times 2 is -18. Okay, so what we must have made a little mistake here. Try to see where I mucked up. Okay, but our intercept should be much lower than that. Sorry, this -3 is squared, sorry. -3 squared. Let's just go back a step. Okay, so really we're going to have -3 times -1 times 2 times -3 times -3. Okay, that makes more sense. So we've got 3 times 3 times 3 is 27. Okay, times 2 is 54. So this value up here is actually +54. Okay, so you can see that I almost slipped up there, forgetting that this term is squared. To find out y-intercept, we actually need to times it by -3 twice. Okay, so that would be our graph of that quartic there. Okay, we'll move on to have a look at this graph here. Now you can see that we actually now got a power 3 and a power 2. So overall we're a power 5, which is known as a quintic. Okay, so we'll have a look at graphing this one as well. Okay, so you can see here we're going to have an intercept at 3 and we're going to have an intercept at -2. Okay, this value here is positive, so we know we're going to be this general sort of shape, this direction. Okay, now we know here at 3, okay, it's a cubic, so it's going to look like that sort of shape. Okay, and here we know this one is quadratic in nature or parabolic in nature because it's squared. It's going to have to look something like that. So overall, our function is going to look something like that. Right, again, we haven't actually worked out our y-intercept, so we can do that. So we've got 2 times -3 cubed times 2 squared. So we can have 2 times -27 times by 4 is 8 times -27. What's that going to be? 160, another 6 in there, so it's going to be what, 216. So it's going to be -216. Okay, so it's quite a long way down. Okay, it doesn't matter, we haven't set a scale on our y-axis until now, so that's fine. Okay, so you can see it's a very similar process to a lot of our other functions. Okay, but you can see factorising, only one way to really do it. Okay, so again, that can be a little bit tricky, but check out some of the other videos on the division of polynomials.